What's up, party people? In this video, we are going to set up terminal to point to our local network on our own terminal server, and we're going to do it by modifying the terminal firmware to point to that server, and we will be completely free of terminal in the cloud, use terminal.com, or any of those guys. So let's start with the BYOS Sinatra client. This is a bring your own server. It's in Sinatra framework, which sits on top of Ruby. And we're going to pull this down. This is the alpha release. And I'm going to pull this down in my native terminal on my machine. Let's do it all from scratch. And I'm going to go into there, and you'll see there's a couple prerequisites. You need to have Ruby on your machine, but otherwise setup should be pretty simple. I'm going to bundle, and then I'm going to rake db setup, which will create a database. And then I can run the app with ruby app.rb. And you'll notice this is going live at localhost 4567 port. But there's nothing at the root, so you're going to want to go to /devices. And here we have just a very simple device CRUD. So I can make a test terminal with a fake MAC address. And once I've created that, it's given a friendly ID and an API key, which you'll recognize if you use terminal native. I can, of course, override those at any time, or I can delete them or add multiple devices. So now that we've got that figured out, let's pull down that server and let's move on to the firmware. Firmware, I'm going to actually clone from Visual Studio Code because we do need to have the platform IO extension installed so that we can build and then upload or flash the firmware to our device. So I've already got that pulled down here, and you can see I'm in parity with this latest commit called refactoring. We need to make a couple changes. If you're deploying this only to your local network, you actually need to make more changes. If you're going to put this on the cloud or on HTTPS, you can make just one change. First, we're going to change the API base URI. That's going to be in this config file. And instead of pointing to the terminal cloud server, we're going to point this to our own local network. I'm going to follow the steps here to just grab my 192.168 network. I'm going to paste that in, and it's 6857. So back inside of my firmware, I'm going to prefix that with HTTP, and then I'm going to add that 4567 port that our Sinatra app is going to run on. So if I was deploying this to the cloud, I would now be done modifying the firmware, but I need to do one more change, which is to allow insecure HTTP requests. And for that, I'm going to search the code base for this star client, and you're going to see this in a few places. One is in this logger, which usually pings the terminal server with error logs. That's now going to ping our server. Next, we have it for the setup endpoint and the display endpoint and the special functions endpoint. So I'm just going to, again, drop this secure client. And I did dig through a little bit of the code in these HTTP libraries in our firmware, but I just couldn't figure it out. They're somehow requiring HTTPS, even with this client set insecure. That's not exactly the same thing. So we've now made a few small changes. Git status, you can see that we've set a new base URI to our local network, and then we've just dropped that secure client option. At this point, I don't need to commit or anything. I'm just going to build it using this build command from Platform IO's extension. While this is up and running, I want to go back over to our web server README, and you can see that we also need to plug this in inside of our Sinatra app. So I'm going to open that Sinatra app inside of Atom Text Editor, a new modern streamlined text editor, and let's go to this app.rb file. Looks like I think I already have it in here right in the source, so you're welcome. And that's now good to go. Back in Visual Studio Code, you can see that our firmware is ready to be flashed. So I'm going to C to clear that out. And now what I'm going to do is I'm going to plug in this deconstructed device, and I'm going to make sure it's turned off. And then I'm going to take USB-C, plug it in. I'm going to hold down the boot button, and while holding the boot button, flip the power switch to on, and now it's looking a little something like this. This should now be in boot mode. So let's go ahead and click this upload button, this right arrow, and we'll know very quickly if I put it in boot mode because it will connect or it won't. And you can see it is connected and flashing. What we need from this is our MAC address. You could, of course, grab this from a mobile app, your router, GUI, whatever, but this is where I like to grab it directly from where we're flashing. And now I'm going to make sure that we're running our server again, Ruby app RB. Let's go and create a new device with the MAC address, and I'm going to call this deconstructed terminal. Now that generated an API key, friendly ID, but you'll see that we can modify, and we probably will modify that in just a minute to sync it up with this particular terminal device. Back in Visual Studio Code, we can see that this is done. Terminal has been flashed, and we now, in theory, have our own terminal stack from firmware from the client to the server, and we're not touching the regular terminal native servers at all. So I'm going to unplug this USB-C cord. I now have this terminal device. I'm going to turn it off, wait a few seconds for the buffer to clear, and then I'm going to turn it on, and it should basically set up as if this was a terminal off the shelf pointing to the web servers. So I'm going to turn this on, and let's switch to camera only. And this should boot up and start by asking me to connect to Wi-Fi. Okay, great. So in this case, this is good to debug. I can see from my logs here that it actually pinged our API endpoint. That's because this is an API key that was stored on the device or in the firmware on the device memory. When you flash the firmware, it does not currently delete old API keys. So what we can do is we can either delete the API keys by resetting our device, or since we're in full control of everything, we can just go to the device that we've provisioned and set that to the API key. And now it should, in theory, ping our server again, and it will match with the API key on our local database. Let's make sure we can see everything. And I'm going to clear the logs here, and I'm going to click the skip button on my PCB, and that should cause a ping. And here we go. You can see that we pinged the API display endpoint, and there was no image, so we just responded with the empty state image, this setup logo. So now for the finale, let's make this a lot more interesting and actually generate real content. So back in my regular terminal, I'm going to crack open a new window and run rake console. This is also documented in the README. So once I'm in rake console, you can see I have some different commands. I can see how many devices there are. This is leveraging Active Record, just an ORM to run those SQL queries. If I wanted to try to get the next screen, I can invoke screenFetcher.call, which is what our device has been doing, and it's just responding with this setup logo over and over again. What we want to do is now generate a screen. So let's go ahead and run screen generator. I'm going to pass in some HTML. Let's try grilling some meats, if anyone remembers that classic film. And then we're going to run process on that. That should now do all of the hard work of creating essentially a bitmap image in the flavor of our application. And now if we go back to our live logs, you can see that it began fetching again, and it responded with that content. So we now have a graphic that we made on our own terminal device, running on our local server, not touching the terminal cloud. There's a lot of things we can do from this. We can build a WYSIWYG live preview to make it a lot easier to build these screens. You can obviously have your BYOS server making requests to a platform in your framework of choice that responds with HTML so that it can pass it into this screen generator. So a lot of things we can do now, but this is the alpha release. Looking forward to your feedback and excited to see what you build. Ciao.